Welcome to Learning with UNP. In this session of Python for Data Science, we are going to understand about looping through set and set operations. That includes understanding about for loop, creating a set from a range, using ranges in for loop, while loop, add, remove, discard, pop element, and finally understanding about update, delete, and frozen set operations. Let's begin with understanding about for loop. Iterating over a set using a for loop allows you to access each element in the set. Because sets are unordered, the order in which elements are accessed is not guaranteed. The syntax to do this is shown here. This line iterates through each item in the set mySet, allowing you to perform actions on each item individually. Let's look at the pseudocode representation of it as a summary of how to do it. First, create a set called mySet. Then, use a for loop to go through each item in mySet one at a time. Inside the loop, you can access each item and perform any operations you need on it. This example demonstrates how to iterate over a set using a for loop. In this example, we create a set called mySet with different types of elements like integers, string, and floating point. Then we use a for loop to go through each item in the set. Inside the loop, we print each item, so the output will display each element of my set, but not necessarily in the order they were added since sets are unordered. Let's execute this and check. As discussed, here is the output. Now, let's look at understanding about creating a set from a range. You can create a set from a range using the set constructor with the range function. The range function generates a sequence of numbers and the set constructor converts the sequence into a set. Here is the syntax of it. This line creates a set of numbers starting from start to stop minus 1, incremented by step. Let's look at the pseudocode representation of it as a summary of how to do it. First, define the values for start, stop, and step to set the range parameters. Then, use the range function to create a sequence of numbers based on these parameters. Convert the sequence into a set using the set constructor and assign the resulting set to the variable mySet. This example demonstrates how to use Python's range function and the set constructor. In this example, the range 1, 10, 2 function call generates a sequence of numbers starting from 1 up to but not including 10 with a step of 2. This means it includes the numbers 1, 3, 5, 7, and 9. The set function then converts the sequence into a set, which is an unordered collection of unique elements. Printing mySet shows 13579 as output. Let's execute this and check. As discussed, here is the output. Now, let's understand about using ranges in for loop. You can iterate over a range of numbers using a for loop and add elements to a set within the loop. This allows you to dynamically populate a set with elements generated during the iteration. This code over here initializes an empty set, mySet, and then add numbers from 5 to 14, inclusive, using a for loop and the add method. After execution, mySet contains integers from 5 to 14. Let's look at the pseudocode representation of it as a summary of how to do it. First, create an empty set called mySet. Determine the starting, start, and stopping, stop values for the range of numbers you want to include. Utilize a for loop to go through each number in this range. During each iteration, add the current number to the set using the add method. By the end of the loop, mySet will contain all the numbers from the specified range, ensuring each number is unique within the set. This example demonstrates how to dynamically populate a set in Python using a for loop and the add method. MySet is initialized as an empty set. The for loop iterates over the range of numbers from 5 to 14, inclusive, using the range of 5 to 15. During each iteration, the current number I is added to the set mySet using add of I. Finally, the print statement prints the output. Let's execute this and check. As discussed, here is the output. Now, let's understand about while loop. While loop are less commonly used with sets because sets are not indexed. However, you can achieve similar functionality by converting the set to a list and using a while loop. This approach allows you to sequentially access and manipulate elements in a set-like manner. Here is the syntax of it. First, it converts a set mySet to a list elements list to enable indexed access. It then initializes I to 0 and iterates through elements list using a while loop. During each iteration, it accesses the current element using elements list of I and increments I to move to the next element until the end of the list is reached. Let's look at the pseudocode representation of it as a summary of how to do it. First, start by defining a set named mySet with various elements. Then, convert mySet into a list named elements list, allowing for indexed access to elements. Initialize an index variable I to 0. Next, use a while loop to iterate through elements list while I is less than the length of elements list. Within each iteration, access and perform operations on the element at index I, incrementing I to move to the next element until all elements have been processed. This example demonstrates how to iterate through a set called mySet by first converting it into a list elements list. MySet is defined with a set containing different elements. Elements list is created by converting MySet into a list, allowing indexed access. A while loop is used to iterate through elements list while I is less than the length of the list. During each iteration, the element at index I of elements list is printed using this statement. The loop continues until I reaches the length of elements list. Let's execute this and check. As discussed, here is the output. Over here, let's look at set operations. First comes add element operation. Adding an element to a set is done using the add method. This method takes a single argument, the element to be added, and incorporates it into the set if it is not already present. Here is the syntax of it. This line adds the specified element to the set mySet. Sets automatically handle duplicates, so if the element is already in the set, it won't be added again. This ensures that all elements in a set remain unique. Let's look at the pseudocode representation of it as a summary of how to do it. To add an element to a set, first create or initialize the set, mySet. Decide on the element you want to add. Then use the add method with the chosen element as its argument. If the element isn't already in the set, it will be included. Otherwise, the set remains unchanged to maintain its unique elements property. This method is straightforward and ensures that sets only contain distinct values. This example demonstrates how to add elements to a set one by one using the add method. In this example, it attempts to add multiple elements to the set mySet using the add method in Python. However, add method can only accept one argument at a time. So, trying to add multiple elements in a single call like this will result a type error because it expects exactly one argument. The same is explained here. To fix this error, we need to call the add method separately for each element you want to add to the set as done here. Let's execute this and check. As discussed, here is the output. Second comes update set operation. To update a set with multiple new elements, you can use the update method. This method takes an iterable, such as a list, another set, or a string, and adds each of its element to the set. Here is the syntax of it. This line adds all elements from the given iterable to the set mySet, ensuring each element is unique. Let's look at the pseudocode representation of it as a summary of how to do it. To add multiple elements to a set, first initialize the set variable mySet. Next, determine an iterable, like a list or another set, that contains the elements you want to add. Finally, use the update method to incorporate all elements from the iterable into mySet, ensuring each element is unique within the set. Here are two examples demonstrating the use of update method to add multiple elements to a set. In the first example, this line adds the elements 4 to 5 to the set mySet, ignoring the duplicate element 3. The set mySet now contains 1, 2, 3, 4, 5. In the second example, this line adds the string elements apple, banana and cherry to the set mySet. The set mySet now contains 1, 2, 3, apple, banana, cherry. In both the examples, output is printed using the print statements. Let's execute this and check. As discussed, here are the outputs. Third comes remove element operation. The remove method is used to delete a specific element from a set. If the element is not found, the remove method raises a key error. Here is the syntax of it. This line removes the specified element from the set mySet, raising a key error if the element is not found. Let's look at the pseudocode representation of it as a summary of how to do it. To remove an element from a set, first initialize the set variable mySet. Next, identify the element you want to remove. Then, use the remove method with the specified element as its argument to delete it from the set. If the element is not found in the set, a key error will be raised. Here are two examples demonstrating how the remove method works in Python sets. In the first example, a set 1 to 3 has the element 2 removed, resulting in the set 1 and 3. In the second example, this line attempts to remove the string welcome from the same set. Since welcome is not in the set, this will cause a key error. In both examples, outputs are printed using the print statements. Let's execute this and check. As discussed, here are the outputs. The same is explained here. Fourth comes discard element method or discard element operation. The discard method also removes a specified element from a set. It does not raise an error if the element is not found. This makes discard method safer for use in scenarios where the element's presence is uncertain. Here is the syntax of it. The discard method removes the specified element from the set if it exists without causing an error if the element is not found. Let's look at the pseudocode representation of it as a summary of how to do it. First, initialize a set variable called mySet. Next, determine the specific element you want to remove. Finally, use the discard method to attempt to remove the element from the set. If the element is present, it will be removed. If it is not present, the set remains unchanged without causing any errors. Here are two examples demonstrating how the discard method works in Python sets. In the first example, a set 1 to 3 has the element 2 discarded using the discard method, resulting in the set 1, 3. In the second example, the same set is used, but this time the code attempts to discard the string welcome, which is not present in the set. Since discard does not raise an error, if the element is not found, the set remains unchanged as 1 to 3. In both the examples, outputs are printed using the print statements. Let's execute this and check. As discussed, here are the outputs. Over here, let me tell you the difference between discard and remove methods. The key difference between discard method and remove method is based on error handling. The remove method will raise a key error if the specified element is not found in the set, whereas the discard method will simply do nothing if the element is not present. This makes discard method safer to use when you don't know if the element is in the set or not. Fifth comes pop operation. The pop method removes and returns an arbitrary element from the set. Because sets are unordered, you cannot predict which element will be removed. If the set is empty, pop method raises a key error. Here is the syntax of it. This line retrieves and removes an arbitrary element from the set mySet, assigning it to the variable element. Let's look at the pseudocode representation of it as a summary of how to do it. First, initialize a set named mySet. Using the pop method on mySet, in the next step, it retrieves and removes an arbitrary element from the set. This element is then assigned to a variable called element. Essentially, pop method allows you to extract and capture an element from the set. Here are two examples demonstrating how the pop method works in Python sets. In the first example, the set mySet contains different elements. Using the pop method on it removes and returns an arbitrary element like 1 or welcome. After printing the popped element and updated set, you'll see the set changed. In the second example, mySet is another set with different elements. Again, pop method is used to remove and return an arbitrary element from mySet. The popped element is then printed, followed by the updated contents of mySet. In both the examples, outputs are printed using the print statements. Let's execute this and check. As discussed, here are the outputs. Sixth comes delete operation. The del statement or delete statement can be used to delete an entire set, removing it from the memory. Here is the syntax of it. This line deletes the entire set mySet, removing it from memory and making it inaccessible or inaccessible for further use in the program. Let's look at the pseudocode representation of it as a summary of how to do it. Here, initialize a set variable named mySet. This sets aside memory to store a collection of unique elements. Second, use the del statement on mySet effectively removes this set from memory, making it no longer available for use in your program. This operation deletes the entire set and any elements it contained, freeing up the associated memory space. This example demonstrates how delete operation removes variables and their associated values from Python's memory space. First, a set named mySet is initialized with elements 1, 2, 3. Printing mySet shows 1, 2, 3 as output. Then, the delete statement deletes the set from the memory. Trying to print or access mySet after deletion raises a name error because variable mySet no longer exists in the program's context. In order to fix this error, ensure that we are not trying to access a variable that has been deleted or is out of the scope. If we need to access the variable later, consider not deleting it or ensuring that it's redefined before attempting it to use it again. The same is explained here. Seventh comes frozen set operation. A frozen set is an immutable version of a set. Once created, elements in a frozen set cannot be added or removed. This makes frozen set useful for scenarios where a constant set of elements is needed. It supports the same operations as a regular set except for those that modify the set, such as add, remove, etc. Here is the syntax of it. This line creates a new immutable frozen set named myFrozenSet from the elements in iterable. Unlike regular sets, frozen set cannot be modified after creation, making them suitable for situations where immutability is desired, such as in dictionary keys or set elements that should not change. Let's look at the pseudocode representation of it as a summary of how to do it. Firstly, you define a variable named myFrozenSet, which will hold an immutable frozen set. Secondly, you use the frozen set constructor to create a frozen set from an iterable, such as a list or a tuple. This constructor ensures that the elements within the iterable are converted into an immutable set-like object. The resulting myFrozen set is now fixed and cannot be changed after creation. Finally, here are three examples demonstrating how the frozen set operation works. In the first example, this line creates an immutable frozen set, myFrozenSet, containing the elements 1, 2, 3, and we print it using the print statement. In here, attempting to remove an element 2 from myFrozenSet using the remove method results in an attribute error. Frozen set do not support modification operations like remove or pop because they are immutable. Similarly, attempting to use pop method to remove an arbitrary element from my frozen set results in an attribute error. Frozen sets do not allow modifications, including operations that change their contents or size. Let's execute all these examples and check. As discussed, here are the outputs. This is all about today's lecture. See you in the next lecture. Thank you.